Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give more examples related to the application of exponential distribution. And here we have x, which is an exponential random variable, and the rate parameter here equals to ln 3. So rate parameter clearly referring to this value here, lambda is equal to ln 3. And you are asked to compute what's the probability that x is between 2 and 4. So here we have this question to be answered. This is quite a direct application. We know that in order to find the probability, well, you need to integrate the function, the probability density function, and the probability density function is lambda e negative lambda x. Hang on, this looks like x. dx, and the limit will be from 2 until 4. And what is lambda? Well, lambda is ln 3, so we can substitute that. Ln 3 e negative ln 3 times x dx. And ln 3 is a constant. You can take it out from the integration process. So ln 3 is out. We've got 4 and 2. And here we have e negative ln 3 with x dx. And we know already how to integrate this function. The result is going to be equal to e negative ln 3x. And at the bottom here, we're going to have negative ln 3. And this will be evaluated from 2 to 4. Well, clearly you can see that ln 3 here will be cancelled out. And we are left with negative. This part here can be written in terms of ln 3 times x, yeah? 2 and 4. And we can just substitute the value of 2 into x or 4 into x, and we do the usual process. So that will be 1 over e ln 3 times with 4 minus 1 e, so ln 3 times with 2. And here you will get the result will be, well, negative, positive will be negative, 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 positive. So I'm going to consider this term in front. So if you evaluate this term, 1 over e ln 3 times 2, the result is going to be equal to 1 over 9. So that's a positive sign, negative, negative, positive. And for this one here, it's going to be a negative sign, and it's equal to 1 over 81. So that's the result when you evaluate this term. And so final answer is going to be 8 over 81. Or you can also express it in terms of decimal points, 4 decimal points maybe. So this is equal to about 0.0988. Okay. Well, that is the first example. Quite a straightforward example. Now let's look at another example here. Okay, in this example, we have the number of Hollywood film stars arriving at the entrance of a private masquerade party per hour is a random variable. So this thing here is a random variable having a Poisson distribution with lambda equals to 30. So what we can see from here, well, we know what is a Poisson distribution. It has a random variable that describes the number of success. So every time the Hollywood film stars come to the entrance, that will be considered a success. So here what we have is we have x. X is the number of success. And here is number of success is number of film stars arriving at the gate, okay, at the entrance or at the gate of a private masquerade party. And X here has a Poisson distribution. We can write in terms of this notation, X is a random variable. It has a Poisson distribution with lambda equals to 30. So this is the value of lambda. And the rate here is given in terms of hours. So this is something that you need to pay attention to. You need to know what kind of interval are they talking about. Is it hour? Is it minute? Is it day? So that kind of stuff you need to pay attention. What is the probability that a security officer has to wait more than 3 minutes? So here we're talking about waiting time. When you talk about waiting time, usually it can be modeled with using exponential distribution. So here we have to wait more than 3 minutes before the next film star shows up at the entrance. So here the waiting time before the next success. So since we already have X to represent the number of Hollywood, so this one here we have to represent with another name. So we can call it Y. So Y is another random variable that represents waiting time. Waiting time. And we know that Y here, and we know that Y here has an exponential distribution. And we can use lambda as a parameter as well for exponential density function. So we're going to have lambda as well. And we know that the probability density function for that is going to look like this, lambda e negative lambda y. So y here is our random variable. And we can also substitute lambda with the value, which is 30 e negative 30y. So that is our probability density function for y. Y is our random variable that represents the waiting time. Now, the question is asking us to find what's the probability waiting time is more than 3 minutes. Now, if you want to translate that in terms of mathematical statement, that means you are looking to find what's the probability that your random variable y is going to be more than 3 minutes. And this is the part where you have to pay a bit of attention, because the question here is given in minutes, but what we have right now is the value of lambda in this probability density function is actually given in terms of hour. So lambda here is in terms of hours. So we need perhaps to adjust the value of 3 minutes so that it corresponds to a unit in terms of hour as well. So what you need to do next is you need to consider, for example, you know that 60 minutes is equal to 1 hour, yeah? Therefore, 3 minutes is equal to how many hour? Like, what's the fraction of hour, okay? So we know that we can solve it with, well, you can solve it with considering, well, we have 60 over 3 is equal to 1 over x. Therefore, we want to know what is it in terms of hour, what is 3 minutes in terms of hours. So that will be x is equal to 3 over 60, which is going to be 1 over 20. So here we're going to change minutes into hours. So 3 minutes is equal to 1 over 20 hour. Okay, so that's what we're going to do. So now we're going to find out. Let me just erase this part. Okay. So now we're going to find out what's the probability that y is greater than 1 over 20. So here in terms of hour. Why are we doing it in terms of hour? Because we already have lambda expressed in terms of hours, so we're just going to use that really, okay? Right, so next we're just going to apply this probability density function right into solving this problem. Okay, so what we have is we need to integrate from 1 over 20 to infinity, and we're going to have this function here to integrate. So we have 30 e negative 30y dy. Okay, let me just continue erasing all this because we don't need this stuff anymore. All right, so 30 here is a constant. We can take it out from the process. Here we got e negative 30y dy, and we already know what's the result of this when you integrate this function. Well, it will be e negative 30y over negative 30. It will be evaluated from 1 over 20 to infinity, and well, you can see that negative 30 here, the value of 30 here can be cancelled out. So what we have is negative can be taken out. So now what we have is 1 over e 30y evaluated from 1 over 20 to infinity. And if you consider substituting infinity into this part, into y, you will get a very large number at the bottom. So 1 over a very large number is going to be equal to 0. Okay, right, so that's the result for that one. We have 0. Now minus 1 over 20, you substitute into y, you will get 1 over e. 30 over 20 is going to be 3 over 2, or 1.5. So 1.5, yeah, just write down here 1.5. And so this becomes positive, negative, negative, positive, and it is equal to 0.2231. So this is the probability that the security officer has to wait more than 3 minutes. The probability is quite small, 0.2. Okay, all right, that's all for now. Thank you very much for watching, and I'll see you again in the next video.